Let's find derivative of log of 1 minus sin x over 1 plus sin x under root with respect to x. Now while solving this sum, what you should be aware of is identity, which is cos square theta plus sin square theta is equal to 1, and also this formula sin 2 theta is equal to 2 sin theta cos theta. Now why? Because before going in for derivation, we have got to simplify the numerical. Now if by any means we can remove this root sign, it would be very easy for us to solve this thing if we can get it into square. Similarly, even the denominator. And if you think a bit, yes, we can. Why? Because if we use this over here, so this becomes a square plus b square, and we are in lookout for 2ab now. If we look into this formula, 2ab also does exist, but this is not 2x, this is x. So what we have got to do is divide it by 2, divide this by 2, divide this by 2. Alright, so now if we get into the numerical, what would it be like? It would be y is equal to log, instead of, now here it is, instead of theta it is x by 2, right? It would be x. Instead of theta it would be x, so it would be 2 sin x by 2 cos x by 2. So obviously even this has to be x by 2 and x by 2, right? So I put in identity first, that is cos square x by 2 plus sine square x by 2 minus 2 sine x by 2 cos x by 2. Alright, this is the numerator part, and similarly it is cos square x by 2 plus so this is what it is. Now don't you think it is a square plus b square minus 2ab, and this also is a square plus b square plus 2ab. So our mission achieved. So y is equal to log, this would be so this is what we end up with. So very simple. So this would be y is equal to log of a minus b the whole square, a plus b the whole square, it's total square, so root goes away. So what we end up with is alright, is it okay? Now what further? Now this doesn't lead us anywhere, but it does if you think a bit. Now suppose if I divide and multiply by cos x by 2, what would I end up over here? I would end up here getting, if I divide entirely. So this also is divided by cos x by 2, this also is divided by cos x by 2. So cos x by 2 by cos x by 2 is 1 minus, this would be sin x by 2 divided by cos x by 2, that would be tan x by 2 divided by, again here it would be 1 plus tan x by 2. Alright, so tan x by 2. Now yet another thing that you should be aware of is tan 45. What is tan 45? Tan 45 is 1, and that is what? That is tan pi by 4. Tan 45 is 1, and that is also equal to tan pi by 4. So if I write here tan pi by 4 minus tan x by 2 upon 1 plus, now this I can also jolly well write as 1 into, so that would be tan pi by 4 tan x by 2. Why did I write here 1? Because it's not going to change meaning, but it's going to help us converting this into formula. So obviously this is what? This is formula for tan a minus b. Alright, so y would be equal to log of, I am not mentioning here, divided and multiplied by cos x by 2, but it is understood. So we end up with this obviously is formula for alright. So it is log of tan pi by 4 minus x by 2, this being a, this being b. Alright. Now it becomes very simple for us to differentiate. So now what we can do is d by dx of y. We know it would be what? We know d by dx of log is 1 by x. So this would be 1 upon, alright, and then d by dx chain rule of, alright. Now we also know that this would be as it is. And tan is sec square. Again further chain rule. Alright. So now it would be and we know d by dx of pi by 4 is 0 as it's constant. And this is minus half into x, so it would be minus half into d by dx of x. So what we end up with is minus half. Right, this minus half, I take it this side, so this becomes now tan is what? Tan is sine over cos. So cos would come up, alright, cos would come up, so it would be minus half. So it will be cos pi by 4 minus x by 2 this, and sec also we know it is cos square, so 1 over cos square. Alright, so I can jolly well cancel this and one of this. So basically what happens is now isn't this equal to sine 2 theta? So it would be minus 1 over sine 2 pi by 4 minus x by 2. Alright, and then if we take 2 inside, this becomes pi by 4 into 2, that becomes pi by 2, and x by 2 into 2 becomes x. So it becomes 1 over sine pi by 2 minus x, and minus sign intact. Now this becomes our allied angle formula, where here n is 1, 1 is odd, so sine gets converted to cos as per rule, so it becomes cos x. But is it positive or negative? Now when we check out our circle, it comes in first quadrant. Pi by 2, this is pi by 2, minus x comes in first quadrant, and in first quadrant sine and cos both are positive, but we are concerned with sine is positive, so here also it is positive. Alright, so it is 1 over cos x minus intact, so 1 over cos we know is sec x, so it is minus sec x. Alright, so that's our answer. So we learned a lot in this numerical, that's why I like this numerical. First part was taking care of root, or rather simplifying the numerical. We did so. Then after that again we did not get proper simplified form where we could do derivation. So we again scratched our gray matter and we got out that if we divide and multiply with cos x by 2, then it gets into format of 1 minus tan x by 2 upon 1 plus 1 into tan x by 2, and 1 obviously we have got to keep in mind is tan pi by 4. So on putting it there intelligently, here also multiplying it with 1 and making it tan pi by 4, and here also 1 converting into tan pi by 4, but here not using tan pi by 4, otherwise we would miss the formula. Alright, and then we got it in terms of tan a minus b. We got that, and then we do. It really became very simple for us. So it was something like this. We converted it into linear equation, and linear equations are always very easy to differentiate. Alright, so most of the time our intention is to convert whatever is in form of fraction, convert that into linear format. So it becomes very easy. It's always easy to differentiate u minus v, u plus v, and so on and so forth. U by v, then it becomes a little complicated, but if it is u by v, then we can. But here we cannot even use u by v because outer bracket is in root. Alright, then it became very simple. But then even after becoming simple, again we applied formula over here and we got this, and then we also used allied angle formula, alright, to get this. Okay, so very interesting sum. Alright, so always I say, whenever you are tackling a sum, you have tackled it, after that revise it, just see what all you have done as I summarize the entire numerical, and it is your job to re-summarize it most of the time. Whenever you are moving ahead, whenever you are progressing in numerical, just recapitulate the numericals which you have already done.